Hello, everyone. Welcome to the Math Magician's Den. We're going to talk about limits that go to infinity today. This first function, 4 over x minus 2. The x minus 2 on the bottom, if I set that equal to 0, it gives me a vertical asymptote at x equals 2. Now, if I plug in 1, I'm going to get 4 over negative 1. That gives me negative 4. If I plug in 0, I'm going to get negative 2. And what you'll notice, this runs along the x-axis down here and goes this direction. And then along the asymptote, it runs to negative infinity. So the limit as x approaches 2 on the left-hand side of 2, it looks like it's going to negative infinity. On the right-hand side, we've got a mirror image through this line, but reversed up. If I put in 3, I'm going to get 4. If I plug in 4, I'm going to get 2. So this graph on this side runs up along that asymptote and then runs along the x-axis for another horizontal asymptote. Now, what is the limit as x approaches 2 from the right-hand side? It looks to me like this limit is going to go to infinity. Now, we notice that those are not the same directions. So if the limit as x approaches 2 is a two-sided limit, I can't say infinity, I can't say negative infinity. I have to say this limit does not exist. And what most people are going to want to say is that the left-hand side does not equal the right-hand side. Well, the left-hand side doesn't equal anything. It approaches infinity, or negative infinity. The right-hand side approaches infinity. So if you're going to give a reason for this limit not existing, we're going to say that this is unbounded. That's going to be our reason, because it involves infinities. Now, the next graph, same kind of thing, except this time I have a vertical asymptote at x equals 1. If I plug in 0, I'm going to get 1. If I plug in negative 1, I'm going to get a half. This graph runs along the x-axis and then shoots up to infinity along the left-hand side, which means the limit as x approaches 1 from the left goes to infinity. If I plug in 2, I'm going to get negative 1 over 1. That's negative 1. If I plug in 3, I'm going to get negative 1 half. You will notice that this graph runs down along that vertical asymptote, and then it runs along the horizontal asymptote at the x-axis. This is the graph that I'm seeing. And you could punch this in your graphing calculators. You could punch it in the Desmos, and this is exactly what you're going to see. The limit on the right-hand side as it approaches 1 is negative infinity. And again, these are not the same thing. So this limit, this two-sided limit, does not exist. And the reason I would give, if I'm asked for a reason, is because these limits are unbounded. Now, the one-sided limits, we're just going to say infinity or negative infinity. The two-sided limit, we have to specify if it does not exist or if it's unbounded. Now, let's keep going on our graphs here. This next one, again, I have an asymptote at x equals 1, but this time the graph goes up on both sides. It doesn't matter what I plug in, I get positive numbers. So it looks like the limit on the right-hand side goes to infinity. The limit on the left-hand side goes to infinity. So this time, when I ask for the two-sided limit, I could say infinity. But when it goes to infinity, that means this limit does not exist. Because when you go to infinity, there is no limit to how high it can go in this case. And our reason it does not exist is because it's unbounded. It involves infinities. And we're going to do one more graph here. This is just the mirror image of this one. It still has a vertical asymptote, but I have reflected it through the x-axis. That negative just takes my graph and flips it over through the x-axis, and I have this instead. What's my limit from the right? Negative infinity. What's my limit from the left? Negative infinity. What's my two-sided limit? Well, it's negative infinity, but again, this limit does not exist because it's unbounded. So when we're talking about limits that go to infinity, it presents situations like this when we're adding and subtracting limits, and what if one of them actually goes to infinity or negative infinity? Well, let's say f of x goes to infinity. but g of x goes to L as x approaches c. So what we're doing here, f of x, if it goes to infinity and g of x goes to L, well, infinity plus L would just be infinity. Infinity minus L would still be infinity. No, L cannot get big enough to negate the infinity. The next part of this problem, it's talking about, hey, what happens if I take infinity times L? Well, that kind of depends on L. If L is positive, this is going to go to infinity. If L is negative, this is going to go to negative infinity. A positive times a negative is negative. A positive times a positive is positive. And this is the one that gets kind of weird. And I hope it makes sense to all of you, because if I take a number L and I divide by infinity, if I let the bottom of a fraction get really, really, really big, it's going to go to 0. In fact, we have this group of limits that we kind of talk about. If you take the limit as x approaches 0 of, let's say, some number 1 over x, okay, let's put in x squared. You're going to get 1 over 0, and that's a positive 0. Now, why is that a positive 0? Because the bottom, when I squared it, they're going to be numbers that are positive that are approaching 0, and we're going to say that's going to infinity. If I do the limit as x approaches 0, and let's say it's from the negative side, 1 over x, this would be 1 over negative numbers that are approaching 0. This would go to negative infinity. Now, if you take the limit as x approaches infinity of 1 over x, 1 over infinity goes to 0. 1 over negative infinity would go to 0. And you can try this. We can actually look at Desmos, and I'm going to just create a different screen here for Desmos. We'll just look down here. And what I'm going to do is I'm going to plug in some fractions. I hope you guys will understand what I'm doing here. We're going to put in 1 divided by a number. 1. We're going to put divided by somewhat of a big number. Now watch as that bottom number gets bigger and bigger. Notice the fraction, the value on the right gets smaller and smaller and smaller. So this is what I mean by a positive infinity. If it goes to negative infinity on the bottom, it still goes to 0. Okay. Now, what if the bottom goes to 0? 1 divided by, let's put in 0.01. You notice that's a pretty big number. So if I let the bottom number approach 0 through positive numbers, the number on the right is approaching positive infinity. If I'm putting negative numbers on the bottom, this is what I mean by a negative 0. The numbers are negative and approaching 0, but that means your overall fraction is approaching negative infinity. It's getting really big, but it's a negative number. So let's talk about some of these properties here that are on this screen. How do we do limits that involve something over 0 or something over infinity? Well, when we do this first problem, I have 1 plus 1 over 0 squared. So this is 1 plus 1 over a positive 0. When you square numbers, they're going to be positive, but those numbers are approaching 0. So this is going to be 1 plus infinity, which is infinity. Now I know to this next problem, there's going to be some more shortcuts. But what I'm going to do is I'm going to just plug in 1. If I plug 1 into the top, I get 1 squared plus 1. That comes out to be 2. Now, if I plug 1 into the bottom, I get 1 over 1 minus 1, which comes out to be 1 over 0. But wait a minute. I am approaching 1 from the negative side. Give me a number that's a little less than 1. 0.9? 0.9 minus 1 is negative. This is a negative 0. These are negative numbers that are approaching 0. The bottom, I should say the top first, the top is still 2. But the bottom, when you put 2 over a negative 0, it approaches negative infinity. And what's 2 over infinity or negative infinity? This fraction goes to 0. Now with trig functions, you almost have to understand where your asymptotes are. If I ask for the graph of cotangent of x, the 3 just stretches it. Cotangent of x at 0, it has an asymptote. Cotangent has an asymptote at 0 and an asymptote at pi. And what cotangent does, cotangent goes downhill. So if you're on the right-hand side of an asymptote, it goes to infinity. If you're on the left-hand side of an asymptote, it goes to negative infinity. Now, we're going to do a few more problems here, and we're going to show you how fast we can actually do these. If you plug in 0 to the bottom of this fraction, you get negative 1 over 7 times negative numbers approaching 0, which is negative numbers approaching 0. 1 over 0 is infinity, but a negative over a negative is positive infinity. I hope you guys see how that works. Same thing with this next one. We're basically putting 5 over 8 minus 8, which is 5 over 0. But we're taking numbers that are to the left of 8, which would be numbers that are a little bit less than 8, which would give me numbers that are a little bit less than 0. 5 over 0 is infinity. A positive divided by a negative is negative. This comes out to be negative infinity. Now, let's keep going here. Plug 8 into the bottom on this one, you get 6 over 8 minus 8, which is 0. So I get 6 over 0 squared. Anything squared is positive. You have to understand the bottom is not 0. The bottom is positive numbers that are approaching 0. When I put in 8 minus 8, this number right here, I'm just assuming those are numbers that are really, really close to 8. These are really, really small negative numbers or positive numbers that are approaching 0, but when you square it, they're positive numbers that are approaching 0. This comes out to be infinity. Now with radicals, we got to be careful when we're doing positives and negatives. We're not really going to worry about it here because of the square, or because of the we're approaching 0 from the positive side, and we have an odd root. This would be negative 8 over 7 times the seventh root of 0 is 0. But those are positive numbers approaching 0. So this would be negative 8 over a positive 0. This comes out to be negative infinity because it's a negative divided by a positive. The next problem is also negative 8 over 7 times 0, but this time there are negative numbers approaching 0. This comes out to be negative 8 over negative numbers approaching 0. What's a negative divided by negative? Positive. And 8 divided by 0 is infinity. Now, I will say this one more time about our trig functions. Trig functions, you have to know what your graphs look like. Tangent has an asymptote at pi over 2 and negative pi over 2. And tangent goes uphill like this. So on the left-hand side of an asymptote, it would go up to infinity. On the right-hand side of an asymptote, it would go down to negative infinity. At 5 pi over 2, there is an asymptote. How do I know? At pi over 2, go pi units later, it would be 3 pi over 2. Go pi units later, at 5 pi over 2, there would be another asymptote. And what's happening on the left-hand side? It's going up to infinity. I hope this video all made sense. If you guys liked the video, please hit the like button. If it seems like this would help you with your calculus, please subscribe to my channel, and I'll be posting more videos later.